Hey guys, actually, have you ever wondered about the traveling the time backwards? Do you know how to travel to your past to make the future change? Well, let's talk about some cases here and the contradictions too. Welcome. So, why we cannot travel back the time? The first condition would be the second law of thermodynamics, which says about the entropy. It says that an entropy should always increase till the equilibrium is reached. So the graph should be always increasing till the equilibrium. Well, the another case because of which the past time travel is not possible is the paradox. Now, this is a 20-year-old guy and another one is himself when he's 10 years old back the time. So, due to some technological changes, there is a time machine which goes through the past. Let's assume this thing. So, this 20 years old boy goes to the past, sees himself 10 years old and shoots himself. He kills his past. Then who was the person who lived this guy till 20 years old, who went to the time machine? Time is weird, really weird. Yeah. Well, do you still want to travel back the time? Well, I've got something for you. Let's consider some incident happening, like a crack, and you see that from a distance as the photons reach your eyes. So all you have to do is travel more than speed of light slanting wise, of course slanting wise, so that you can just recatch those photons which are coming from that incident, and yeah, you see that thing again. Well, all you have to do is to break the law of physics and to travel past the speed of light. Well, in a nutshell, you catch the photons through your visuals and then travel more than speed of light, recatch the photons coming from that incident, and yeah, you see that thing again. Well, good luck breaking the speed of light. Well, and another case for the time travel backwards is none other than the gravitational waves. Yes. Well, you must have all heard of the space-time or the fourth dimension. Well, a quick fact is that when the gravitational waves are formed, the time around it flows backwards. You must have heard this fact from somewhere. Well, the space-time sometimes looks like this. Alright, I'm drawing this. The space-time looks like this and it will bend when we place a highly massive object on it. It is what called as the gravity stretching time. Well, now let's consider that in two dimension. Well, we did one dimension, and we put a massive object like Earth. The space-time bends very less, but it bends. Now we are placing Sun in it. It bends a lot. The time travels faster in the Sun. And now neutron star, it bends a lot. It bends tremendously. Neutron stars are the densest. Well, the fact thing is that when the gravitational waves are formed, this is a person in the, we can say, in a massive planet. And there's a person which is in a least massive planet, so the space-time isn't bending. The person on the massive planet says that it's been 2 minutes. Well, he measures the time for some times and says that it's 2 minutes, and the same person measures the same amount of time and says it's been 1 minute. 2 minutes and a 1 minute, a huge difference. Well, now let's consider the relative space-time, which is a very least massive object, we can say, because nothing is relative here. And the gravitational waves are the waves formed to the space-time. So let's consider a person on the, we can say, the trough part, and one person on the crest part, and the one person on the relative space-time. A person on the crest part says that it's been 5 minutes. It measures a certain interval of time and says it's 5 minutes. The person on the normal part says that it's been 3 minutes, and the person on the trough part calculates the same measure of time and says it's been 2 minutes. Well, then the person on the trough part is definitely traveling the time backwards, relative to others. Relative is a big word here. Well, as some big scientists said, that the time is relative, always. Thank you very much for watching. Subscribe for more.